Christian Vega, February 3rd, 2023.
Within our hospital, we don't really use oxygen tanks for direct delivery. While under anesthesia, we use something called an oxygen compressor that compresses air that is filtered into and somewhat concentrated that delivers the air in a somewhat continuous stream. As the oxygen moves from the high pressure tank into our anesthesia machine, it looks like the pressure is lowered by our regulator to provide a safe pressures between 45 to 50 psi. The pressure gauge measures the force of the pressure in water or air, and that helps you determine if you have any errors within your systems or the tank itself. From the pressure reduction valve, the oxygen travels through a pressure hose toward the flow meter. The flow meter allows the anesthetist to provide specific measurements in the amount of oxygen delivered to the patient. The oxygen flush valve, for instance, in an emergency situation, it can deliver large amounts of fresh oxygen. It will completely bypass the vaporizer, so therefore no oxyfluorine or gas anesthetic will be delivered to your patient. And here we have our vaporizer, which our oxygen travels and converts our liquid anesthetic into a gas for gas anesthesia delivery to the patient. Alrighty, and our vaporizer here is a precision vaporizer, just because I'm able to control in the percentage or amount of anesthetic gas that is delivered to our anesthetized patient. After the oxygen travels through the vaporizer, the ISO and the oxygen enters a hose that assists in delivering fresh gas to the breathing circuit and then through to the patient. Here we have our rebreathing circuit, which means they're just rebreathing recycled gas. The continuous cycle is typically used on our adult patients or patients that are large, and then for our smaller breed dogs, we tend to use our non-rebreather, which just means that they are breathing fresh gas and oxygen. So anything that's less than 7 kilograms, we tend to use a non-rebreather circuit. With our rebreathing circuit, the exhalation valve functions as the flow of gas through our machine is circular. So it travels through the reservoir bag, inhalation valve, and then the inspiration hose, and then our expiration hose, then through our exhalation valve, then through our carbon dioxide canister, and then back to our inhalation valve. And then here we have our pop-off valve. We use the Supera pop-off valve. And then so there's an extra step when closing it. Here's an example of our reservoir bag. Fresh gas is entering the circuit and then travels to an inflatable rubber bag. The bag, it fills with gas entering the circuit and is deflated with inhalation. Our pressure manometer measures the pressures of the gases within our anesthetic system, and it measures using centimeters of water. Our anesthetic waste gas is neutralized in the CO2 absorber or soda lime canister. And back here we have our scratching system, which travels just outside of the building. Here I am setting up my rebreathing system. The inhalation portion of the circuit gets placed in the inhalation valve, and then the other one gets placed in the exhalation valve. Alrighty. How I leak test my rebreathing system is I go ahead and close my pop-up valve and turn my flow meter up to a high setting. I'm using an artificial lung to leak test my machine. And I want to make sure it holds at least 20 centimeters of water.
Yeah, I zoomed out first.
And to do that, I crank my flow meter down to about 0.2 liters of oxygen per minute. So about 200 mils. And it holds pressure, so my machine leak tested well. With my non-rebreathing system, I go ahead and connect my non-rebreathing system to the inhalation valve. And then the other tube is connected to the fresh gas inlet. So you can see they're not going to rebreathe any of the recycled gas. All the recycled gas gets scavenged out. I go ahead and connect my bag. And same concept when leak testing this machine. I'll go ahead and close up my valve here. And then crank up my oxygen up to a high setting. And like the last breathing circuit, I want to make sure it holds at least 20 centimeters of water. So once I hit about 20 centimeters or more, I'll go ahead and crank it back down to 0.2 liters per minute or 200 mils per minute. This machine held really well, so it passes the test. What is not used in a non-rebreathing system is the pop-up valve, manometer, and soda lime canister.